What if I ask you a question like, find the sum of all numbers between 1 to 100? You might go, okay, so 1 plus 2 equals 3. 3 plus 3 equals 6. Stuff like that. But I want you to notice, here's the very easy way to solve it. What is 100 plus 1? That is 101. Right? Now, let's take the next number after 1. And then we take a lower number after 100. So 2 plus 99. That's 101. And it works for all, and there's 50 pairs of numbers. Because 100 is even, and you just divide by 2. And you get 50 pairs of these, and all of them equal 101. So, because all 50 pairs equal 101, that means we can just multiply 101 by 50. And that should be easy math for you. That would be this. $5,500. You just added 100 numbers in a very easy multiplication. Now that works for 1,000. Let's try 1 to 1,000 numbers. Just multiply 500 by this, by 1,001, and then you get. Okay, so we 10,000 and 10, 100,000 and 100. You get 500,000 and 500. Now you did that for 1,000 numbers. It even works for any amount, any even number. Let's see. Let's try 1 through 50. What is that? There's 25 numbers, so we multiply 25 times 51. And 25, we can simplify it by saying 25. So we take this number. Let's divide it by 4. Let's take 51 divided by 4. So we know that 48 is 4 times 12. So let's see, what is 51 minus 48? That equals. What is 51 minus 48? That equals. Wait, I could make a better 8. 51 minus 48 equals 3. So now we can just divide. So we now got this number plus 75. Because this 1,200 is just 25 times 48. So we get this. Oh, and I'll give you another problem. What is the sum of all natural numbers? Meaning 1 plus 2 plus 3 plus 4 plus 5, all the way on to infinity. And you might go, well, obviously it's infinity, but that's not the right answer. It's actually this, -1/12. And you might go, how can adding a positive number be a negative number? And how can adding natural numbers or even integers lead you to a fraction? Well, let's just call this sequence S. I know that's 5. But yeah, let's just call it S. So we shift our so we just So we have another sequence called S1. And that, well, it equals 0. Well, you might think it equals 0. Because in reality, it's just 1 minus 1 plus 1 minus 1 plus 1. And then it goes on and on. What if we take S1 and we subtract 1 from it? Actually, we take the number 1 and we subtract S1 from it. So so we'll put a 1 here, and then it's minus, and then it's plus, and then it's minus. 1 minus 1 plus 1 minus 1 plus 1. And that means, and because we got the same thing, that means that this equals this S1. So you can probably do basic algebra here. So you add the S1s on both sides. So now 1 equals 2S1. Now divide both sides by 2. So now we know that S1 equals 1/2 instead of 0. Now let's go to another sequence. It's called S2. It's kind of similar to the original thing we're trying to solve, but it's 1 minus 2 plus 3 minus 4 plus 5, and it goes on and on and on. The even numbers you subtract and you add the odd numbers. Now, what if we add 0 to it? So, because we're adding 0, nothing really changes. Now, let's take another S2 and add it. So we're just multiplying this by 2. So we now have 1 minus 2 plus 3 minus 4 plus 5 minus 6. And you might notice that if you add these, you get a 1, get a minus 1, and then you just get a plus 1, and a minus 1, and a plus 1. Now we're just multiplying this by 2, so remember this sequence? It is S1. So if S1 equals 2S2, and we know that S1 is 1/2, that means we just divide a half by 2. That means S2 is 1/4. So now let's go back to our S. Remember S is the thing we're trying to talk about. S equals 1 plus 2 plus 3 plus 4 plus 5, and it goes on and on and on. Let's subtract S2. So 1 minus 2 plus 3. So remember, we're subtracting this. So if we were to change it into adding, we need to find negative S2. So negative 1 plus 2 minus 3 plus 4 minus 5. Now you notice that the odd numbers are opposite, so they cancel each other out because this is addition. And the even numbers, they just get multiplied by 2, so you're now left with 4 plus 8 plus 12 plus 16 plus 20, and it goes on and on and on. A sum of multiples of 4. Now, let's factor out 4. So we now get our old sequence. Remember this is just, this entire sequence is just S. And because we're multiplying S by 4, we get 4S. So S minus S2 equals 4S. So we just subtract S from both sides. And we get negative S2 is 3S. And we know what S2 is. It's 1/4. So we know what negative S is. It's negative 1/4. 3S, divide both sides by 3, and you get 1/12 minus 1/12 equals S, where S is the sum of all natural numbers. I'm going to write this in summation notation. This is mind-blowing, right? But you might ask, what about the sum of negative numbers? Well, technically this is kind of like subtraction, but this is the best way to show it. This is just adding negative numbers to another negative number. It goes on and on and on. Well, let's say we have a sequence like negative 1, plus 1, minus 1, plus 1, minus 1, plus 1, minus 1. And it goes on and on and on. Now let's add 1. So 1 plus x equals x. This doesn't feel right. So what if, we know that if we use the distributive property, like negative 2 plus negative 2 plus 3, that's just negative 2 minus 3, which is just negative 5. So why don't we do it this way? We take our normal S which means we take negative of a negative 1/12. So that means that, and these two cancel each other out. So that means the sum of all negative numbers is 1/12. Shocked, right? So, thank you for watching. Please like and subscribe to the channel. Thank you for watching. See you in the next video. Oh, and before you continue to watch in the next video, the technique that I just showed you is called Ramanujan summation. Yes, that's correct. The greatest mathematician of all time, Srinivas Ramanujan, proved that the sum of all natural numbers is negative 1/12. See you in the next video.